Welcome back to tutorial number 14 on transceiver controls. You're doing the Foundation Theory radio course with the Radio and Electronics School. In this tutorial we're going to talk about the controls on a typical amateur transceiver that you should know about for your assessment. There's one thing I want to mention. When you go for your assessment, you are not being assessed excuse me, on using a particular radio. If the assessor or the place where you go for your assessment has an FT1000 or an IC708 or whatever, you are not being assessed on your knowledge of that radio. You're being assessed on your knowledge of amateur transceivers in general. Therefore, if you know the major controls and you can't find it on the radio you're being assessed on, you can say to the assessor, please show me where the VFO is on this radio. Please show me where the RF gain is. Please show me where the mode switch is. Because you're not being assessed on using a particular radio. You're being assessed on using an amateur transceiver in general. Therefore, you really need to learn a small group of controls and what they do so that you can ask for them and use them during your assessment. This slide is of a typical HF amateur transceiver. This is going to be the sort of transceiver or something like it that you're going to have in your assessment. Because the radio could be unfamiliar to you that you're assessed on, you really need to learn these controls. If you know the radio, then you'll be able to know and use those controls. But if you don't know the transceiver you're being assessed on and you want to know, for example, where the power switch is, you can ask the assessor where the power switch is if he hasn't already turned it on for you, and so on. So what I'm going to do is go through all of these controls, their location on the radio, and basically what they do. But do remember that the layout of every amateur transceiver is different. So the power button might be in the top left or it might be down here. So you need to learn these controls and what they do, and if you need to use them and don't know where they are, you can ask your assessor. For our purposes of going through the major controls on an amateur transceiver, we're going to use an IC718. And the first control, and this radio is representative of all amateur transceivers. There are a couple of things this transceiver does, and it only goes from 160 to 10 meters, so it doesn't have VHF and UHF in it. But it will do very nicely for our purposes of going over the major controls of an amateur transceiver. I've made a list of the controls that you need to learn and what they do. So I'm going to go through each one of them and show you where they are on the radio and tell you basically what they do. Just remember that when you do your assessment, if you remember all of these controls, you will be able to say to the assessor, where is the power button, where is the AF volume, where's the squelch or mute, and so on, and he will show you during your assessment. Rightio, let's have a look. Power is how you turn the transceiver on and off, and usually it's clearly marked with PWR or power. That is how you turn the transceiver on and off with the power button. It will have one somewhere if it's not this type of transceiver. AF volume. AF stands for audio frequency, and it's just like the volume control on any radio. It turns up the loudness of the receiver. But on an amateur radio, it's called AF volume or AF gain. The AF volume or AF gain on this radio is this knob here. The reason why it's that knob is this is a dual knob. There's a knob around the outside and there's one on the inside. How do I know it's the one on the inside, which is the the AF gain control? Because see the symbol there? The inside of the symbol is pointing to AF. So the inside of this knob, the internal knob, is the AF gain control, or volume of the receiver. The next one is the squelch or mute. It's called a mute on FM, and it's called a squelch on AM, single sideband SSB. It's called a squelch, and on FM it's called a mute. And the purpose of the mute is to remove any noise from the receiver when there's no signal being received. If you listen to a radio receiver and it's not receiving a signal, you'll just hear noise. So you can turn the squelch up to cut that noise off, and the receiver will be quiet until a signal is received. And the squelch control on this radio is this outer ring here. We've got an inner ring, a middle ring, and an outer ring. And this lever here is the squelch control. So you'd rotate that in a clockwise direction until you heard no sound coming out of the receiver. So that eliminates the receiver noise when there's no signal present. Very easy control to use. The RF gain, very important control. The RF gain is the control that changes the sensitivity of the receiver, not the volume of the receiver. The AF volume does that. The RF gain increases the sensitivity of your receiver, making it possible for you to receive weaker signals. If you're receiving strong signals, you don't want the RF gain up very high. If you're receiving weak signals, you want it up very high. If you're checking to see if a frequency is in use, you should turn the RF gain up very high to make sure your receiver in your transceiver is set to maximum sensitivity. And the RF gain is this control here on this radio. So you would rotate the RF gain in a clockwise direction to increase the receiver sensitivity. If your mute was open, if your squelch was open and you rotated your RF gain up, you would hear the noise increase. The band switch. The band switch is how we change bands. We might want to operate on the 80 meter band, the 40 meter band, the 20 meter band, or the 10 meter band, whatever. If the radio is capable of operating that on that band, it will have a band switch to move between the various bands, the amateur radio bands. And on this radio, that's these two controls here. They say up and down, but they're really band up and down. So if you're on the 80 meter band and you pressed up, you would go to the 40 meter band. If you pressed up again, you might go to the 20 meter band, and so on. If you press down, you come back a band. So it's just a simple up-down switch for the band switch. Older radios used to have a rotary switch, and you had to switch the band in that you want. These days, most amateur transceivers are computer controlled, and it's a simple up and down switch. It might say band up or band down. On this transceiver, it just says up or down. The VFO, the variable frequency oscillator. The variable frequency oscillator is always the big knob on the radio. Big round knob on the radio as a rule. And when you rotate that knob either direction, either rotate it right or rotate it left, you will see the frequency change on the radio. The VFO is the way you change your transmit and receive frequency on your radio. So if we rotated this right, we're on 14.195 megahertz now, we would be going up in frequency. If we rotated left, we would be going downwards in frequency. The mode. The mode is the mode that we want to transmit on. The modes the common modes are amplitude modulation, that's double sideband. We call double sideband amplitude modulation. That's really a misnomer because AM is really double sideband is the proper name for it. But it's commonly referred to as, they are the one thing. So your mode switch is how you change to AM or double sideband or single sideband. Or you might want to operate on CW, Morse code. You would need to operate the mode switch to change between these different modes of operation. The mode switch on this radio is here. Just one thing about the mode switch, if you're going to measure power, you need to choose a mode that has a carrier. And the modes that have a carrier that are on the slide are AM or CW. FM, this radio doesn't have FM, but FM would also be a suitable mode to measure power because these, or tune up an antenna, because FM, CW and AM, not SSB, FM, CW and AM have a continuous carrier. So after you announce yourself with your call sign, you've still got a continuous carrier without talking so that you can make adjustments in SWR or power or whatever. The RIT. The RIT stands for Receiver Incremental Tune. When you set the, suppose we set the transceiver to this frequency and we were talking to someone and their transceiver wandered a little bit off frequency. Say their transceiver wandered up 10 or 20 hertz up or down from this frequency. If we changed our transmitter frequency to their frequency, when we transmitted back to them, they would have to adjust their VFO again. And then when they transmitted back to you, you would have to transmit your adjust your VFO again. So the RIT enables you to change your receiver frequency. Here's the RIT. It's the outer knob. This is the RIT here, this knob. The receiver incremental tune, or RIT, enables you to change your receive frequency without changing your transmit frequency. So if the operator that's transmitting to you is slightly off frequency, you can use your RIT to get him nice and clear without changing your transmit frequency. That being the case, when you transmit back to him, he won't have to make any adjustments to his receiver. That's the receiver incremental tune, or RIT. Selectivity. Selectivity is the ability of a receiver to reject unwanted signals and just receive the wanted signal. To be able to make a receiver more selective, radio amateurs generally have to have filters installed in the receiver. So if you're a real keen Morse code operator, a CW operator, you would have a crystal CW filter fitted to your radio. You have an SSB filter, 3 kilohertz wide, already fitted to your radio, and some radios have multiple filters for different modes fitted to them. Others, you have to, when you buy the transceiver, the filters are an optional extra from whoever you bought the radio from, and you have to fork out some money to be able to plug them in. The Selectivity on this receiver, a transceiver, is controlled by this switch here, the filter. So you can switch in different filters of different bandwidths to control the selectivity of the receiver. Power output or microphone gain. The power output on single sideband is controlled by the microphone gain. So if you had a power meter attached to this radio, that went to a power meter, an SWR meter, when you're transmitting, you can adjust your power output by adjusting the microphone gain. The microphone gain is very important because it controls your power output on single sideband. On this radio, there is no obvious microphone gain. On most radios, you will find a knob which says microphone gain, which is also your power control on single sideband. On FM and other modes, the microphone gain or power output is normally adjusted by entering the menu system of the radio. Normally on HF transceivers you will have a microphone gain switch. This one is a little bit different because to change the microphone gain you actually have to enter the menu system of this transceiver. So what I've done is brought up a part of the operating manual which explains how to use the microphone gain on this transceiver. Here it is. Setting the microphone gain. The microphone gain must be adjusted properly so that your signal does not distort when transmitted. Number 1, select SSB or another mode. A phone mode is radio telephony. Number 2, press the set button for 1 second and then enter the quick set mode, and so on. I'm not going to explain this to you, all of it, because you don't need to know it. What's important is that the radio that we're looking at doesn't have on its front panel a microphone gain control. You have to enter the menu system by pressing the set control and adjust the microphone gain by looking at the display here. You'll see a bar come up and tell you what level the microphone's set up. Very important control because it's the output power control on single sideband. The carrier control. The carrier control is only used on modes that have a carrier, and those modes are double sideband. That is what most people refer to as AM, FM, and CW. Those modes have a full carrier. Single sideband has a suppressed carrier. So the power output is as much a function of the level of the carrier as it is to the microphone gain. And on this radio there is no carrier control knob on the transceiver. Again, you have to go into set, and that set, I'm not going to take you through the procedure because there's no point. You may be using a different radio, but if the radio does not have a carrier control to adjust your output power on these modes, it will be obtained by going into the menu system. You do not have to learn the menu system of a radio. The assessor will help you with that. You just have to know that the carrier control is used to control the carrier power on double sideband and FM and CW. Well, that's it for the major controls on a transceiver. Not too hard. You should endeavour to remember all of these controls and what their operation is. Do not remember the radio, because goodness knows what sort of radio you'll be assessed on. But when you are assessed, you can simply say to the assessor, where is the VFO? The VFO is always the big knob. You won't have any trouble finding that one. You won't have any trouble with the RF gain. But on this particular radio, you do have to go into the menu system to adjust a couple of things such as mic gain and carrier control. Well, that's it for tutorial number 14. I hope your course is going well for you. This is Ron, VK2DQ. Thanks for your attention, and I'll see you in the next tutorial. Cheers for now.